Jai Hind everyone. Myself Mukesh Kumar Singh. I'm working in Ajay Kumar Garg Engineering College in the Department of Information Technology. I'm going to discuss one of the most important topic of database, that is database normalization. Before going to deep discussion of the database normalization, we have to understand something about the uh, normalization process. It means what are the problem. Due to that problem, there is involvement of the there is need of database normalization. First, these are the actually there are some anomalies. Due to that anomalies, our database is not so good, not so much efficient. That's why we have to reduce all these anomalies. What are these anomalies? We have to discuss. First anomalies, it is that is data redundancy. It is data redundancy. Due to data redundancy, there might be some values that may be repeat. We have to take one example. Let's suppose we have a student table. In student table, there are various record. For example, student roll number, subject ID, student name, branch, and subject. Let's suppose we want to insert subject ID of some student. Let's suppose I have taken 10 and I have taken the student taken again another subject. Then there are, what are the possibilities? These two names are repeating 2 times. Branch is repeating 2 times, and their subject, database and database, these are repeating. What these are repeating in the anomaly in database. What are impact of this repetition? Impact of this repetition is there is unnecessary utilization of the memory. That's why this type of repetitive values is known as data redundancy. In normalization process, we have to remove the data redundancy. This is the first anomaly. Second anomaly is insert anomalies. What happen in insert anomalies? In an insert anomalies, there is a, let's suppose we have a student table again, and we want to insert a subject ID. Let's suppose it is 15, and no student has adopted this subject ID. Then how we have to insert the, without opting the subject ID, we cannot insert the student roll number. Such type of anomalies is known as insert anomalies. What will happen in this insert anomaly? Let's suppose we want to insert some data item, and the database, we want to insert some data item, and in database without existence of the other attribute. That's why we cannot insert such type of values. This type of anomalies is known as insert anomalies. In insert anomalies, in normalization, we have to also remove insert anomalies. Next anomalies, that is update anomalies. What will happen in update anomalies? Let's suppose again I am taking one student table. What is in student table? Let's suppose we have a name Muthu, and second name is Muthu. If someone updated the address of student, let's suppose he have any database administrator has updated the address of this one. What will impact if he will not update the address of this also? Then what will happen? There will be inconsistent in database. There will be inconsistency. Why? Because Muthu one address has something and another address is something. So that's why this type of anomalies is known as update anomalies. We have to solve in normalization. We have to solve such type of anomalies also. Last one is the delete anomalies. What will happen in delete anomaly? Let's suppose again I am taking student table. In student table, we have the following records. In this record, let's suppose due to any reason this course crypto, it is deleted by anyone. Yeah, this course is ended. What will happen if this course will ended? Then we have to remove this. If we have to remove this, then the record of this one is also removed from database. This record by default that will be removed. So such type of if we are removing one value, due to that value another value will be also replaced. If such type of anomaly occur in database in relation, this type of anomalies, uh, if such type of anomalies exist in table, we have to handle such type of anomalies also. So after discussing in these anomalies, there are actually 4 type of anomalies that occur in database. First one, data redundancy. Second one, insert anomalies. Third one is update anomalies, and fourth one is delete anomalies. Now we have to understand the normalization. What do you mean by normalization? Actually, in normalization, what we have to handle? We have to handle all these anomalies. Whatever the anomalies I have discussed, we have to handle the data redundancy, insert anomalies, update anomalies, and delete anomalies. In database normalization, we have to handle all the normalization. Now we have to go for the definition of the normalization. What do you mean by normalization? Yeah. What we can understand from the normalization. Normalization is the process of structuring and handling the relationship between data and minimize redundancy in the relational table and avoid the unnecessary anomalies properties from the database like insertion, update, and delete. What will happen in normalization? In normalization, we have to remove the anomalies. What we have discussed earlier, we have to remove anomalies like insertion, update anomalies, delete anomalies. This is involved in the normalization. What will the second point of the normalization? Let's suppose we have table. We have a large table. What will happen in normalization? We have to divide the large database, large relation into a smaller table, so that and there exists a relationship between all the tables. This is second point of the normalization. And third, we have what will happen in normalization again. It can remove the redundant data and ease to add, manipulate, or delete the table field. What we have discussed in the definition section of the normalization, we have to take one example. Let's suppose we have a database, a student database. There are some records. What are these records? These records are student ID, student name, subject, and professor, and their contact number. Let's suppose in class there are 60 or 65 students, and we have written here student ID, here we have written the student name, here we have written the subject, here name of professor, and their contact number. Let's suppose someone opted database and name of professor this, and their contact number is. What will happen if we look clearly in this table? What is going on in this table? In this table, there are some values that is repeating multiple times. Let's suppose name of professor, that is repeating multiple times. Contact number of professor, that is repeating multiple times. What problem occurs this repetition? What problem can due to the repetition? What problem faced by the user, database user? If let's suppose someone want to change the contact number of this professor, what will happen? If we change all this number, there are multiple updations. Let's suppose his name exists 10 times. We have to update 10 times. What will happen? And that's why what we will do, we have to modify, we have to normalize the given table. We have to break the table into different two sub tables, so that this type of anomalies does not exist in table. This is the example why need we normalization. Next, we have to understand the objective of normalization. What should be the objective of the normalization? First point is that actually what will happen? It used to remove the duplicate data item in database anomalies from the relation. As discussed in previous example, what should be our objective? Let's suppose this is the table. What should be our objective? There are if there are repeating of one value is multiple time, we have to remove such type of anomaly. This will be the first objective of the database normalization. Second objective, what will happen? What helps normalization? It reduces redundancy and complexity by examining new data type used in the table. What happened? what will happen by applying normalization? After normalization, what will happen? It will reduce the redundancy of database, and if it is more complex, then what will happen? The complexity also reduce. Third point is it is useful to divide the large database table into smaller table and link them by using the some relationship. Fourth point, what is fourth point? It avoid duplicate data or no repetition group into a table. And fifth point, it reduces the chances for anomalies to occur in the database. These are the some objectives which should be followed in the database normalization. Now, if we will discuss the types of normalization, there are 6 types of normalization. First one is the first normal form. Second is second normal form. Third normal form. Fourth normal form. Fourth, that is bi-coded normal form. Fourth one is bi-coded normal form. Fifth is fourth normal form, and sixth is the fifth normal form. These are the types of normal form that is in general used to ask in various exam, AKTU exam. Now we have to discuss one by one each and every normal form. First, we have to discuss the first normal form. It is one of the most important normal form. First normal form. We have to define what is the definition of the first normal form. How we have to identify the first normal form. A relation. Let's suppose we have a relation. Let's suppose we have a relation. It is a relation. This is the table, and it contains attribute A1, attribute A2, attribute A3. This contains some attribute. When we call this relation is in first normal form, there are some condition. On the basis of that condition, we have to identify whether given relation or given table is 1NF or not. A relation is in 1NF if all values stored in the relation are single and atomic values. What do you mean by this statement? Let's suppose we have draw a table. Again, I am drawing table. It is a table. Let's suppose student ID SD, student ID, S name, and phone number. Let's suppose and check, and I'm going to identify whether the given table is 1NF or not. Let's suppose student ID is 10, name is Arnav, and he have multiple phone numbers. Let's suppose 6395 is one phone number and 8584 is another phone number. So if we ask whether this table is 1NF or not, what will our answer? We have to go in definition. What is definition of first normal form? It says that all values stored in relation are single valued and atomic. What will happen in table? In given table, in taken table, there is a student ID. There is the one name against student ID, and there is multiple values. That's why this table is not in the first normal form. What are some more conditions whether given table is first normal form or not? A relation is not in first normal. Let's suppose a relation is any relation is given, whether it is first normal form or not. There are some conditions. A condition is that if any relation contain composite value. Let's suppose this is a relation. Let's suppose I have taken a relation R, A, B, C. It is a relation. In this relation, if it contains composite value, then that relation should not be in the first normal form. And second, what is second? If it also contains multi-valued attribute. If any relation is given and that relation contains multi-valued attribute, then that relation is not first normal form. Third condition is that if any relation contains nested relation, it means attribute whose value for an individual tuple are not atomic. Let's suppose here it is 10, it is one tuple, its values are not atomic because it contains multiple values. That's why this relation is not in the first normal form. These are the some conditions. Based on these conditions, we are able to identify whether the given relation is first normal form or not. I'm revising it again. What should be the condition of first normal form? A relation will be in first normal form if all the values stored in relation are single valued and atomic. If it contains composite attribute, if it contains multi-valued attribute or it contains relations whose values for an individual tuple are not atomic, then that relation will be not in the first normal form. Now we have to take some example for clear understanding of the first normal form and how we have to convert the first normal form given table into first normal form. We have to take one example. Now this is the table. Let's suppose is a author table. In this table some values are given. What are these values? These values are, first values ISBN, second attribute is title, third one is the author name, fourth one is the first. These are the attribute. We have to identify whether this given table is first normal form or not. What are the condition of first normal form? We have to identify whether all values are atomic or not. Let's suppose we have to check this one. ISBN. What is title of this balloon? It contains more than one value. Author phone number, it also contains more than one value. That's why this table is not in first normal form. What will have not in first NF? We have to convert the given table into first normal form. What are the rule to identify? If in any tuple there are multiple values, or there are composite values, or there are nested relations which values for individual not atomic, then that table is not in the that relation is not in the first normal form. Now we have to decompose. Let's suppose this is the table. In this table is not the this table is not in the first normal form. We have to convert this table into first normal form. How we have to convert? There are some steps we have to follow that step. These steps are, first step is we have to place all items that appear in the repeating group into new table. Let's suppose here there are two attributes, that is author name and author phone number. They contain multiple values, multiple repeating value, multiple values. What will how we have to convert? We have to place these two into different table. That's why here author name and author phone number, we have to place this into different table. Second, we have to designate a primary key for each new table. After decomposing this table into two different tables, we have to designate some primary key for both the table, and duplicate the new table of the primary key of the table from which repeating group was extracting, or vice versa. For example, let's suppose here ISBN is a primary key. We have to designate primary key of this table into second table also. Here is also ISBN number and here is also ISBN number. This is the way to convert given table into first normal form. Now we have to take one more example. This is the relation. We have to identify whether this relation is in first normal form or not. What are the property? How we have to identify whether given relation is first normal form or not? So in this table there is SSN, this is primary key, e-name, and there is a project. This project contains multi-valued. Why? Because this project contains P number and hours. What will happen in first normal form? In first normal form, composite attributes are not allowed. That's why we have to convert this this relation into first normal form. How we have identified whether that is in first normal form or not? So how we have to identify? We have to identify that this project contained multiple attributes. That's why it is case of composite attribute. If any relation contains composite attribute, that relation is not in the first normal form. What will happen? We have to convert the given table into first normal form. How we have to convert? We have taken SSN number and e-name in one table, and P number and hours another table. We have to connect that table with previous table. So there is a primary key, that is SSN number. That's why we have placed SSN number here also. That becomes into first normal form. Now we have to take one more example. how we have to convert the relation into first normal form. This is the department table. In department table, this contain multiple values. This is not first normal form. Why it is not first normal form? Because a tuple, research tuple, it contains multiple values. That's why we have to convert the given relation into first normal form. How we have to convert? We have to just take this research and we have to repeat different values. Here, we have to take in first attribute research, and this Bellary, second Sugarland, and third Houston, and remaining are the single value attribute. That's why this table is converted into the first normal form. Now I have to discuss the second normal form, one of the most important normal form, that is second normal form. What is definition? How we have to understand first normal form? Let's suppose we have a relation. We have to identify whether that relation is second normal form or not. What is the rule? What is definition of the second normal form? That first, a relation is in second normal form if it is in first normal form. What is the first condition? Let's suppose I have given a relation R, A, B, C, and I am asking a question whether that relation is second enough or not. What is the first step? First, we have to check whether the given relation is in first normal form or not. If it is not first normal form, then we cannot convert it. We cannot say that it is in second normal. First, we have to convert given relation into first normal form. If it is in first normal form, and second condition, every non-prime attribute is fully dependent on each candidate key. This is the second. What do you mean by this statement? Every non-prime attribute is fully dependent on each candidate key. It means we don't have any partial functional dependency. It means in relation there should not exist any partial functional dependency. Now we have to understand what do you mean by non-prime attribute. Let's suppose first we have to understand non-prime attribute and we have to understand fully functional dependent, and we have to understand partial functional dependence. Then definitely we can convert given relation into second NF. First we have to understand the concept of the non-prime attribute. Let's suppose we have a relation. Let's suppose we have a relation R, A, B, C, and there are some FDs, there are some functional dependency. It is A tends to B and B tends to C. Now we have to find out all the candidate key. What will be the candidate key? Here candidate key will be A. A will be the candidate key. A will be candidate key and BC is not a candidate key. BC is, if any attribute is not part of the candidate key, then that attribute is non-prime attribute. Let's suppose I have taken one more example. Let's suppose we have a relation relation A, B, C and D. Let's suppose AB is candidate key. AB will be, if any attribute that is part of candidate key, that will be the prime attribute. That will be the prime attribute. And if any CD is not part of candidate key, that's why it will be non-prime attribute. If any relation is not part of candidate key, then if any attribute that is not part of candidate key, that attribute is non-prime attribute. And if any attribute is part of candidate key, that attribute is prime attribute. Now we have to understand the concept of fully functional dependent and partial functional dependent. Let's suppose there is a FD, there is a functional dependency AB tends to CD. We have to understand this example. Let's suppose AB tends to CD, C, and B tends to D. Clear? We have two FDs, and here key is AB is candidate key. AB is A and B both are combining. If we are combined two attributes, that become the candidate key. Now we have to understand the partial function dependency. What is the partial? What is the subset of AB? It is A and it is B. That is the subset of AB. If any functional dependency that exists either A tends to something or B tends to something, that is in the category of partial dependency. It means A and B, if there is exists AB is candidate key, and if there exists a functional dependency that is derived from either A or B, then such type of dependency is known as partial dependency. It means something is derived by the part of candidate key, not the whole candidate key. In this example, let's suppose AB is a prime, AB is candidate key. What AB is a candidate key. In candidate key, here it is fully functional dependent. I'm not looking for this side. First, I'm going to give you concept of the partial. What do you mean by partial? AB is not partial. Why AB? Because AB is a candidate key, but B tends to D. Here B is part of candidate key, subset of candidate key. That's why this is in the category of partial functional dependency. Now we have to understand. I have told about the prime attribute and partial dependency. Let's suppose we have a relation. We have to check whether the relation is second normal form or not. What we have to check? If in given relation, left hand side of the if in given relation, LHS is proper subset of any candidate key and RHS is not prime attribute, then it is not in second normal form. Let's suppose we have given a relation AB tends to C and B tends to D. How to check whether that relation is second NF or not? We have to check. First, we have to find out the candidate key. Let's suppose AB is a candidate key. We have to check left hand side of FD, that is proper subset of part of candidate key, and right hand side is not is a non-prime number, then that relation is not in second NF. Here it is AB is not part of key, that's why it is in second NF. But in this side B, left hand side, that is B is part of AB, that's why it is not second NF, and D is definitely is a non-prime attribute. So this way we can identify whether the given relation is CNF or not. Now we have to take some example to convert relation into second normal form. Let's suppose this example is given. A relation R is R. Let's suppose we have an example. Let R ABCD is a relation, and there are some functional dependencies. What are these functional dependencies? AB tends to D and B tends to D. We have to check whether the relation is in second normal form or not. If it's not in second NF, we have to convert relation into second normal form. What is the first step? First step to check whether the given relation is second normal form or not. First step is we have to find out the candidate key. First step, we have to find out the candidate relation. It is given AB tends to D and B tends to C. How we have to find out the candidate key? It is very simple step. We have to check those attributes which is not appearing on the right hand side. Relation is A, B, attribute is A, B, C, D. You have to check whether which relation is not exist in the right hand side. D is existing and C is existing. In right hand side, A and B is not existing. That's why whatever the key, whatever the candidate key, AB will be part of the candidate key. First step. How we have to identify candidate key? You have to check the FD's functional dependencies, and in FD's you have to check which attribute is not appearing on the right hand side. Here A and B is not appearing on right hand side. That's why A and B will be the part of the candidate key. Then what will be the second step? We have to just take closure of AB. It is deriving all the attributes, then AB will be the candidate key. Now we have to take closure of AB. AB derive closure of AB will be AB, and AB derives D and B derives C. That's why A, B, C, D. If we perform closure of these two attributes, then we will get the ABCD. That's why candidate key will be the AB. This is the candidate. This is the our first step. If any relation is given and we have to convert the given relation into second normal form, then what will be the first step? First step is we have to find out candidate key. What will be the second step? After finding candidate key, we have to find out the prime attribute and non-prime attribute. I have told that key if here AB is candidate key, whatever the attribute that as part of candidate key, that will be the prime attribute. That's why A attribute A and B are the prime attribute, and remaining attribute, which one? C and D, these are the non-prime attribute. First we have to identify which attributes are prime attribute and which are non-prime attribute. All those attributes which are the part of the candidate key, that is the prime attribute, and those attributes which are not the part of candidate key, that is the non-prime attribute. Third step, for every functional dependency, we have to check whether that follow the rule of the second normal form or not. If that is not following, that is violating the second normal form, rule of second normal form, then we have to break that relation into two different table. Now first we have to take AB tends to D. We have to check whether that is in second normal form or not. We have to check first AB tends to D. Here AB, what is AB? AB is candidate key. Here AB is candidate key, and this AB is not the part of not the subset of AB. That's why. And D, what is D? D is non-prime attribute. Here I have already told that C and D are non-prime attribute. Here we have to check whether that is violating our second normal form. So first we have to identify whether it is partial dependency or not. No, it is not. It is fully functional dependent, because AB both are the candidate key and AB derives a non-prime attribute. That's why this relation, this functional dependency AB tends to D is in the second normal form. Now we have to check the second attribute, that is B tends to C. In B tends to C, B tends to C. C is non-prime attribute and B is the part of the candidate key. That's why it is partially dependent. It violates the second normal form. I'm repeating it again. What is candidate key? AB, and part of candidate key, subset of AB, that is B. Subset of candidate key is deriving the non-prime attribute. This is violating the second normal form. That's why this relation is not in this functional dependency is not in the second normal form. We have to divide the relation into two different relations. We have to take R1 and second one R2. In R2, it contains B and C. Why B and C? Because due to this FD, it is violating the property of the second normal form. And second, that is AB tends to D. It contains A, B, D. So we have converted, this was the relation, and we have converted this relation into two different relation, and these two relation are, this is also in second NF and this is also in second NF. Both are the second normal form. Now we have to take one more example. A relation R A B C D E F having some functional dependencies. These are the functional dependencies. We have to convert the relation R into second normal form. What is the first step? First step, we have to find out the candidate key. What will be the candidate key? We have to check which attribute are not appearing on the right hand side. In this, there is A not appearing. In this, A is appearing. So this rule exactly not applicable. Then what we have to, how we have to identify? We have to take closure. How we have to take closure? Start from the functional dependency. First, we have to take closure of A. What will happen? Closure of A will give A, and A derived B, C, D, E, F. B, C, D, E, F. Closure of A is able to give all the attributes. How many attributes are there? A, B, C, D, E, F, and A, B, C, D, E, F. That's why A will be the candidate key. Now we have to identify some more candidate key. We have to take closure of BC. BC plus. What will be BC plus? BC plus, it means BC. What is deriving BC? It is deriving A, D, E, F. A, D, E, and F. This is the, and after performing closure of BC, it will give BC, A, D, E, F. That is all the attribute of relation. That's why BC also a candidate key. In the given relation, there are two candidates. Now we have to check for this one. B tends to F. If we take closure of B, it will give B and F. That's why it is not giving all the attribute. It is not the key. It will not be the candidate key. Now we have to take D tends to E. In D tends to E. If we take closure of D, it will give D and E. And it is not all the attributes of the relation. That's why it is not the candidate key. There are two candidate key, that is A and BC. This is the first step. After finding the candidate key, we have to identify prime and non-prime attribute. I have told earlier that what is the prime attribute and what is non-prime attribute. Here, this A and BC are the candidate key. And second step, we have to find out the prime and non-attribute. Those key which are the part of candidate key, that will be the prime attribute. There are three prime attribute, A, B, and C. Remaining D, E, and F, these are the non-prime attribute. This is the second normal form, second step. Now in third step, what will we have to check for each and every FD, every function dependency, whether that is violating property of second normal form or not. Now first we have to check A tends to BC. A tends to this functional dependency. A is a candidate key. If we divide A, we cannot divide, and a candidate key is deriving the non-prime attribute. That's why it is in second normal form, because non-prime attribute DEF is fully functional dependent on candidate key. We cannot, it is not the part of candidate key. That's why it is in second normal form. Why? Because A and BC are the candidate key, and A is candidate key. A is able to derive non-prime attribute. Which one is non-prime attribute? D and DEF. That's why it is in second normal form. Now we have to take again second functional dependency, that is BC tends to this one. Here BC, what is BC? BC is candidate key. BC is able to derive DEF, non-prime attribute. That's why, and BC is not part of candidate key. It is a candidate key. That's why it is also in the second normal form. Now we have to take D tends to E. Here D tends to E is second normal form. Because why it is in second normal form? Reason is that D is not a part of candidate key, and E is not a E is a non-prime attribute, and it is not partially dependent. That's why it is not violating the second normal form. Now we have to check B tends to F. It is violating the second normal form because B is part of BC and F is a non-prime attribute. The relation B tends to F is a it violating the second normal form. That's why it is not in the second normal form. We have to break the given table into two different tables. What will be the two different tables? It will be the first relation we have identified it is B tends to F, which is violated the property of second normal form. That's why we have to break the relation into two parts. First part is this one, R1, it contains these FDs, and R2, it will contain B tends to F. That is all about the second normal form. Thank you for watching it.